Imagine a world where communication no longer depends on electromagnetic waves, radio frequencies, or even physical media. A world where information is transmitted instantly, not through space, but through the very fabric of existence itself. This is the theoretical domain of zero-mass transmitters, a frontier idea in the physics of communication that challenges everything we think we know about distance, energy, and causality. The concept begins with a simple yet profound question. What if massless transmission didn't rely on particles like photons at all? In today's world, even our most advanced communication systems, fiber optics, quantum key distribution, deep space laser relays, depend on the motion of energy-bearing quanta. Even light, though massless in rest terms, carries momentum and interacts with matter. But what if information could be sent without the exchange of energy, without a carrier particle, and without loss? That's the thought experiment that gave rise to the term zero-mass transmission. At its core, zero-mass transmission proposes a radical method of information transfer that bypasses conventional fields entirely. Instead of encoding data onto electromagnetic or gravitational waves, the information is imprinted directly into the quantum vacuum state, using shifts in the underlying probability structure of reality. In essence, you're not sending a signal through space. You're rewriting how space itself defines the state of information at two distant points. It's like whispering across the universe by editing the rules of existence rather than sending a sound wave. To understand why this idea is so enticing, we need to explore the quantum vacuum. Contrary to the name, the vacuum isn't empty. It's a seething ocean of virtual particles constantly popping in and out of existence, governed by the Heisenberg uncertainty principle. These fluctuations form a background fabric that permeates all space-time. Scientists have long suspected that the vacuum might be an information field of its own, a universal substrate capable of storing and transmitting data without conventional energy expenditure. Zero-mass transmitters would, in theory, operate by manipulating the phase states of this vacuum field. Instead of radiating a signal outward, they would induce synchronized quantum perturbations that resonate identically at two or more locations. The result? Perfectly instantaneous communication, completely immune to interference, distance, or even the speed of light. Imagine interstellar probes communicating in real time, without delay, no matter how far apart they are. The implications for space travel, computation, and civilization itself would be staggering. To appreciate how such a system might work, consider quantum entanglement, the phenomenon where two particles share an instantaneous connection, regardless of distance. When one is measured, the other's state collapses in perfect correlation. While current entanglement can't transmit classical information faster than light, zero-mass transmission could take this principle a step further. Instead of relying on particle pairs, it would use the vacuum's universal coherence as a bridge. Essentially, every point in space could become an entangled node, part of a cosmic-scale communication grid. But how would you write information into nothingness? One hypothetical method involves vacuum topology modulation. The vacuum, while appearing uniform, might have dynamic geometric properties at the Planck scale, tiny folds or twists in spacetime itself. By introducing controlled distortions through high-energy field stabilizers, a transmitter could impose a pattern on the vacuum's local topology. On the receiving end, a tuned sensor array could detect the matching quantum fluctuations as a data stream. In this model, communication becomes a matter of topological resonance rather than signal transmission. The benefits of such a system would be profound. Because no energy is radiated, zero-mass transmitters would produce zero signal loss, zero interference, and total stealth. They could operate across interplanetary distances without any degradation. The latency of light-speed communication, like the 20-minute delay between Earth and Mars, would vanish entirely. Spacecraft could coordinate with each other as if they were a few meters apart. Even the concept of distance in communication would dissolve. The societal transformations would be immense. On Earth, global networks could evolve into a unified consciousness grid, with every device, brain, and AI connected through vacuum phase synchronization. Communication could transcend bandwidth. Imagine neural implants exchanging terabytes of emotional or sensory data instantly. Knowledge could be shared not as files or speech, but as direct experiential states. Humanity could, for the first time, think collectively. Of course, the physics behind this concept remains purely theoretical. We don't yet possess a model that allows controlled manipulation of vacuum topology, nor a way to confirm that it could encode retrievable information. But emerging research in quantum field dynamics, zero-point energy, and space-time engineering hints that such control might not be entirely impossible. In laboratory settings, Casimir effect experiments have shown that we can already modify vacuum energy density between closely spaced plates. If those modifications could be made dynamic and tunable, we might have the first stepping stones toward a primitive zero-mass modulator. Consider, for instance, a quantum lattice of superconducting qubits designed not to compute, but to phase lock with the vacuum fluctuations surrounding it. When millions of these qubits oscillate in harmony, they could form a coherent field imprint, slightly altering local vacuum structure. If a distant lattice, similarly configured, tunes itself to the same oscillation pattern, both could synchronize at a quantum level. No photons exchanged, no signals sent, just mutual state resonance. This would mark the first experimental instance of zero-mass communication, even if only over microscopic distances. But the implications go far beyond physics. Imagine the philosophical and ethical questions that would arise from such a system. If every conscious being could connect through a zero-mass communication web, individuality could blur. Privacy, distance, and even the idea of self might dissolve into a collective information field. Wars fought over misunderstanding could vanish, because misunderstanding itself would vanish. On the other hand, the loss of informational isolation could threaten autonomy. Would a global mind be paradise or imprisonment? Then there's the potential military and surveillance dimension. A zero-mass transmitter would be undetectable by any conventional means. No radio signature, no traceable emissions. Intelligence agencies or rogue states could communicate invisibly across any distance. The very concept of secure communication would be redefined, not because it's encrypted, but because it's physically impossible to intercept something that doesn't travel through space. Economically, entire industries would collapse and reform overnight. Telecom infrastructure, fiber, satellites, cell towers would become obsolete. Data centers could vanish, replaced by vacuum phase information nodes that require no cables or servers. The internet itself could evolve into a quantum field-based continuum where storage and transmission become one and the same. Energy consumption for communication would drop to nearly zero. Humanity's digital footprint on the planet would shrink dramatically, aligning technological growth with sustainability. Still, achieving such a leap would demand breakthroughs at the edge of our current understanding. We would need a unified field theory that bridges quantum mechanics, general relativity, and information science. We'd have to find ways to engineer stable perturbations in the vacuum without catastrophic side effects, since even minor distortions could ripple through space-time unpredictably. The challenge wouldn't just be technical, but existential. How do we safely interact with the foundation of reality itself? One possible safeguard might involve quantum buffering fields, which localize vacuum distortions to prevent cascading effects. Similar to how particle accelerators contain high-energy collisions within magnetic confinement, zero-mass transmitters might require containment layers made of exotic materials, perhaps negative mass composites or metamaterials capable of stabilizing Planck-scale geometries. The creation of these materials alone would constitute a revolution in applied physics. Beyond communication, zero-mass transmission could unlock new forms of computation and energy distribution. If information can be transferred instantaneously without energy, then computation itself might occur non-locally. A processor in one galaxy could collaborate with another across billions of light-years as if they were a single unit. The universe could effectively become one infinite distributed computer, operating on the substrate of reality itself. And what about consciousness? Some researchers already speculate that the brain may interact with quantum processes to generate awareness. If so, then zero mass transmission might also allow the sharing, or duplication, of conscious states. Imagine transmitting not just words or images, but your entire subjective experience to another being, instantly. Teaching could become direct experiential transfer. Empathy could become literal. The arts, education, and relationships would transcend language itself. Yet such intimacy with the quantum fabric of existence might expose humanity to dangers we cannot yet conceive. Disturbing the vacuum could have unforeseen consequences: temporal instability, causality drift, or feedback loops between parallel universes. Some physicists warn that manipulating zero-point energy fields could trigger catastrophic resonance, destabilizing space-time on a macroscopic scale. A miscalibrated transmission could, in theory, erase information, permanently, from the universe's memory. Despite these fears, the pursuit continues, at least in the realm of theory. Private labs and advanced research divisions have begun experimenting with vacuum state resonance, exploring the quantum noise floor of existence for patterns. Some claim that anomalies detected in ultra-cooled vacuum chambers could be the faint signatures of natural zero-mass interactions, cosmic events where the universe itself exchanges information without any medium. If so, then zero-mass transmission might not be a human invention at all, but a natural property of reality waiting to be harnessed. Imagine what civilizations a million years ahead of us could do with this technology. They might communicate across galaxies in perfect synchrony, maintain unity across vast star empires, or even converse with alternate versions of themselves in parallel universes. For them, zero-mass transmission would be as commonplace as radio is for us, an invisible thread connecting every consciousness across time and dimension. So, what would the dawn of zero-mass communication mean for us? It would mark the true end of isolation, not just physical, but metaphysical. We would step into an era where communication, thought, and existence merge into one seamless continuum. The line between sender and receiver would vanish, between human and machine, between now and forever. Zero-mass transmitters represent not just a technology, but a philosophy, a declaration that information is not bound by the limits of matter or energy. It is the pulse of reality itself, capable of moving faster than light, deeper than time, and closer than the atoms that make us. The question isn't whether we can build them. The question is whether we're ready for what they'll make us become. Hey everyone! If you enjoyed this video, make sure to hit that like button, drop a comment to share your thoughts, and subscribe so you don't miss any of our future uploads. Your support helps this channel grow. Thank you for watching.